Greetings, M squared here. Today we are going to talk about using completing the square to change a quadratic equation from standard form to vertex form. So hopefully you remember what standard form and vertex form are. Standard form is when you have the x squared term, then the x term, then the constant, so it's in that order. Vertex form looks like this, where you have an a, then an x minus h plus k, where hk is the vertex. So it's much easier to graph when we have it in vertex form, because the vertex is right there, then we can use our 1, 3, 5 pattern to graph. So that's our ultimate goal, is to get it into this form so we can graph it. So you're going to be quizzed just on changing it into this form and finding the vertex, but in class we're going to graph it as well. So I'll try to do one of those like that. So here's the steps. First, we're going to rewrite it. So if you notice in this, y is on one side and everything else is on the other side. So we're really doing everything to just one side of the equation. So we're going to rewrite the equation. We're going to leave a little bit of room between bx and c, so the linear term and the constant. Then we're going to factor a out of just the first two terms, the quadratic and linear terms. We're going to leave a little bit of room at the end, because we're going to add half of b squared to that space, and then we're going to subtract it beyond c, because remember, whatever we do to one side we do to the other, but since we're doing it both to the same side, we're going to add it and then subtract it. Let's see, did I say that? I did not say that. Find the new b, add it before c, figure out, we're going to subtract it later, but we got to actually figure out what we add or subtract first. I forgot that I added those little notes. And I'll explain that in a minute, because just because you add it inside the parentheses doesn't mean you really added that number, because we factor out an a and we have to remember distributive property. So we're going to figure out what we really added or subtracted and then do the opposite after c. Then we're going to factor like normal. Okay, so first off, we want to just rewrite it. So I rewrite it, y equals 3x squared minus 18x. This is where I leave my little gap, because I'm going to do some stuff in there. So I'm going to factor out my 3 from this. So I want you to see what I'm doing here. I'm factoring out a 3, so I still have my 24 here. I'm factoring out a 3 of just these two, which means I divided both of those by 3. So this divided by 3 is x squared, and this divided by 3 is negative 6x. Notice I'm just factoring out a. That's not the greatest common factor because there's an x, but I don't want to factor out the x. I want the x squared and x in here so I can get that to be the trinomial square. Inside these parentheses is what's going to be my perfect trinomial square that I'm going to factor. So I just factored out the 3. Then just looking at my new b right here, I'm going to find half of b, which is 3. I'm going to square it, and I'm going to add it to both sides. So, well, sorry, I'm going to add it inside here. Okay, so half of that's 3 squared is 9. So on the other day, when a was 1, we just added 9 here and subtracted 9 here. But I really didn't add 9. I added 9 inside the parentheses, but because there's this 3 being multiplied by all of these things, I really added 27. So if I really added 27, then I have to subtract 27 out here, because that 3 times 9 is 27, so I've got to subtract 27. So that's the tricky part of today. So now I'm going to rewrite it in factored vertex form. So I'm going to factor this trinomial square, which is x minus 3. And then I'm going to combine these, which is negative 3. And when it's in vertex form, then remember, I can just take the opposite of that number, and then whatever this number is. So my vertex is 3, negative 3. I'm going to remind you how to graph that. I'm just going to sketch a quick graph. I would go over 3 and down 3, and that would be my vertex. And then because a is 3, my 1, 3, 5 pattern, normally I would go over 1, up 1, over 1, up 3, over 1, up 5. But because a is 3, I don't do 1, 3, 5. I multiply all those by 3. So my pattern turns out to be 3, 9, 15. So I'm going to go over 1, up 3, then over 1, up 9, and then I would graph that like that. I'm not going to graph all of them, I just want to show you, and you're going to do it on graph paper, but that is just the easier way to do it, to get it into vertex form rather than graphing it from this. All right, well, let's try another one. So again, first step is me just rewriting it. and leaving a little space, and then factoring out the 8. So when I factor out a, this is my a, I'm going to divide both of those by 8. So I'm going to get x squared minus 2, and then 2x is going to be there. Now I'm going to take half of b, which is 1, square it, and I'm going to add it inside the parentheses. But in order to find out what to subtract out here, since I added it here, I've got to multiply by there. So that's a positive 8, so that means I'm going to subtract 8. So I get 8. X minus 1 squared equals, sorry, not equals, the y equals is over here. This should be minus, let me write it out because I don't want to see that go, minus 5, because 3 minus 8 is 5. So my vertex turns out to be 1, negative 5. Alrighty. We're going to try 2 more. Okay. So you can pause and try to do it on your own and see if you get the right answer. We're going to go ahead. So again, I'm going to skip a step here. I'm going to take out the 4x first. I mean the 4 first, the negative 4. Notice a was negative 4, so I took out the negative 4. And that becomes a little bit tricky, so I'm going to show you how to do that. You're just going to divide by negative 4. If you remember that, you probably won't mess up on your signs. But if you try to factor out, you might forget the negative. Because if you divide by negative 4, this becomes positive, but then this becomes negative. 16 divided by 4 is 4. All right, so I'm going to take half of 4, negative 4, which is negative 2, square it, which is 4, and I'm going to add it here. But what did I really do? I really just subtracted 16. So if I really subtracted 16, I have to add 16 over here. So when I rewrite it, I get y equals negative 4 times x minus, remember it's half of that, squared, plus 21. So my vertex then is positive 2. It's the opposite of what we see there, 21. Now, just remember, when this is negative 4, we remember that the negative tells us it's upside down. So when you graph it, it's going to look, like this. We know that our pattern is going to, instead of 1, 3, 5, it's going to be 4, 12, and you won't be able to go beyond that. But anyway, that's kind of a skinnier one. All right, last one. So we're going to, again, rewrite it. I'm going to factor. I'm going to kind of skip that middle step. I'm going to do 2 steps at once, really, not skipping. So I'm going to divide both of those by 5. So I get an x squared minus 2x. So then I'm going to add 1 here, because half of 2 is 1, squared is 1. Negative 1 squared is 1. So now I'm going to factor. Oh, sorry. Got to tell me what I added. I added 5, so I'm going to subtract 5. So y equals 5 times x minus 1 squared minus 12. So my vertex is 1, negative 12. And usually when I do these, I would just go back and I check, okay, did I make sure I did the opposite? That was negative 1, this is positive 1. That was negative 2, that's positive 2. That's negative 1, so that's positive 1. Just to make sure I did that, because it's an easy thing to forget when you're going at it. So good luck with changing to vertex form when a is not 1. M squared signing out.